important, you should turn in your Windows Security Academy scores. Go to the page that shows how many of these things you've completed and turn in the image in Canvas. There's a place that says turn in WSA scores. You get 10 points for every one you've completed. If you don't get them turned in, then they won't be included in your midterm grade. Now, the midterm grade doesn't really matter much for most students. It's the final grade that really matters. But anyway, if you want to make sure you get all your points for your midterm grade, turn in that image, because we have no way to see your Web Security Academy scores if you don't send us the picture, because we don't know what username you have. We don't have the ability to log into those accounts. It's not integrated with the college in any way. So you got to turn in a screenshot. And if you don't know how to do it, take a look at the project W600, which is here, and I've got an example here of there. This is the page you want. Your progress showing how many apprentice, how many practitioner, how many expert you've done. These numbers are all 0 here, but there'll be more than 0 for you, presumably. Hopefully you've been doing 2 of these a week for a while or more, and every one of them is worth 10 points. So that's, you'll want to turn that stuff in now, and also turn it in at the end of the class to the final grade. Can I include IY for the final? I have enough points for the midterms. I don't know what IY is, Rouser. Maybe it's perhaps? Yeah, I mean, just turn in whatever you've got. Yeah, I mean, you'll just turn in an image here. Yeah, okay, good, glad you heard. Yeah, turn this in, and if you already have enough points for midterms, but anyway, all that matters is the final. And you may, if you've done a ton of these, you might already have enough points. Yeah, anyway. Good, and you'll see in Canvas an announcement telling you how many points you need for an A and a B and C and so on. So, all right, anyway, that's the most important thing. Remember to turn that in so I can give you the right midterm grades. And then we'll just get to the official stuff here, which is Chapter 8 and the start of Chapter 9. So, here's Chapter 8. All right, so access control. We talked about this a lot. First you have to make sure you know who somebody is by having them log in, and then you have to have access controls specifying what they're allowed to do. If they're the administrator, they can do things. If they're not the administrator, they can't do things. So you must remember to always test who somebody is before you let them do anything. And this is extremely common. It's probably one of the most common web vulnerabilities of all, is that you forget to test for some of the actions whether this person is authorized to do it. And that's called insecure direct object access, or a variety of things, unprotected APIs, where there's some function that should only be available after you've logged in, and they forget to check that, and you can do it without logging in properly first. This happens all the time. And so it leads to various kinds of vulnerabilities. Privilege escalation. Vertical privilege escalation is the one you most commonly think about, where you can somehow move from a low privilege account like user up to administrator or root. And that's, of course, dangerous, and there are a lot of these. They appear in both Linux and Windows frequently. You have to keep everything really updated. And in your web app, these things also tend to be possible. Another one is horizontal privilege escalation, where you can move to another user of the same level without having more power, but you can move into another user's account, like getting their bank account, getting their email. And of course, that's bad too, although it's not as bad as moving to administrator, which would let you get in everybody's stuff. And there's also context-dependent privilege escalation, if you like, where you can move to some place you shouldn't be able to do in context, like performing tasks out of order. Like ordering a product and then skipping the part where you pay for it, but still getting the part where they ship it to you, for example. That would be moving horizontally through the app in a way that you're not supposed to be able to. So the most common thing is here, completely unprotected functionality. There's a page or a function on the app that you can run that forgets to check who you are at all. So anybody can just do it. They call this unsecured direct object access, or security through obscurity. You have like a page and it's hidden, and you hope people won't find it. But if they do find it, they can use it without having to log in first. So you can just look and try to look for all the URLs of secure activities. You might find links to them, and you might find things that build links, like this JavaScript looks like. It's building a link here. It's going to add some code to the URL, so you may have to construct it out of chunks from the source code. But you find these things that do something. So here, for example, is something that lets you view a document with a document ID. And the question is, if you had to pay for these documents, did it somehow make sure that you paid for it first? And people might make a server where you pay, you buy the thing, then they send you the link, but the link itself is unprotected. So you could then share that link with other people, and they could all see it without paying for it. That's one way you can design these things. And this happens pretty often when developers just find it too difficult to connect to the authorization page, and they do this simple way, which the reason why it happens so much is if you do this, it will work for your authorized users. The people who pay will see the documents, so you won't have complaints from users saying something's wrong, but you won't know that there are extra people getting the documents that didn't pay for it. You probably aren't logging that. That's why this happens so often. This can persist for a long time without anybody noticing that it's happening. All right. Also, your document identifiers might be predictable, so you can move from one document to another. All right. Of course, if it made sure you paid for it first, that wouldn't be so bad. All right. And so then there's multi-stage functions like select a new user, select department, select role, enter username and password, and maybe it enforces access control for one of these steps, but not for the later steps. So maybe I can just skip right over this step, right to the end, and do this without having to, prove who I was on the way in between. All right, and then there's like I say, staying for a book, go to a static file, but it's an unsecured direct resource. That means anybody with the URL can download the book. So it'll seem to be fine for a while until people start sharing these links, and then you'll realize that people are getting the book without paying for it. Then you can restrict certain paths like admin. That usually takes the form of rules. Now, unfortunately, these rules often are incorrectly configured. One common thing is Apache security rules. They will restrict it by the request method, the URL path, and often the access control rule only applies to a certain method like post or get. So it only applies to post. You can get there with get. Also, sometimes you can implement, you can go to head and it will execute it. And also, you can often misspell get, like GETT, and the server will treat it as get, but the security rule will not recognize it as restricted. So that's called verb tampering. That's the kind of thing. It tends to happen. This happened, I showed it last night in Android apps. This tends to happen, and it also happens in Apache configuration files, that you can be restricting just one method, and other methods do not see the restriction. And so then there's parameter-based, referrer-based, and location-based access control, and all these are pretty dangerous. So you have a privilege level in a hidden field, like you have admin equals true. And of course, the problem is anybody can use burp and just change that admin from false to true and then become the administrator if it's controlled over the client-side thing. You can add or modify the parameter to get in. You might use the referrer to say if they're coming from another page on my site, that proves they already logged in. But as you know, you can just forge the referrer, so it doesn't really prove that you came from that page. That's why the right way to make sure people come from your page is to have a hidden random field on each page, which is submitted to go to the next page that you verify. That proves that they really came from my page number 2 to go to my page number 3. The referrer doesn't prove anything because it can be forged and altered. And of course, location restrictions, we all know this. You'll have sporting events or something that's geo-fenced. You can't access it from certain locations. And there's a lot of ways to bypass it. I did an Iranian capture the flag contest maybe 15 years ago. And one of the first challenges was to change your apparent location to like 30 different countries. Because apparently in Iran, everything is blocked. So everybody there learns how to use proxies to make their location go anywhere. And that is considered a fundamental skill. So you use proxies as the most common one, where you reroute your traffic through a server in the other country, like England or Spain or something, and then you appear to be in that country. You can VPNs are a common solution. You can use a mobile device and move it. You can do direct manipulation of client-side things, like change the GPS on your phone and such. Anyway, another thing you can do, and this happened, I did just to solve a student question last time. There are often two responses that are only slightly different, and burp will help you find even small differences. So here's a content that was accessed in two user contexts, and logged in as one user and logged in as another user. It will highlight the few characters that are different in the two cases. And a common use is when you get the username wrong, you get a denial page. When you get the password wrong, you get a denial page, but they aren't exactly the same. One of them might take longer to load or have a period or a tab or something on it, and that's something you can use you can exploit. So burp makes it easy to compare two pages and highlight the difference. And like I say, the number one simplest problem is direct access to methods. So just log in as administrator, get to places and see where you're going, and then try to get there without being the administrator and see if you can get there anyway. All right, so here's a request that goes on the IBM HTTP server. And so you walk through the app while logged in as an administrator, notice the high privileged resources, log in as a low privileged user, and see if you can still get there. And that's a simple way to test it. All right. Try other methods and see if you can do them if they low privilege account, that sort of thing. Don't assume that the user can't find something, because even the user might be able to predict that. And by the way, Google is incredibly good at crawling your site and finding all the pages. So even if you put something up there and you didn't put any link to it, and you think it's a long, complicated name, Google will tend to find it. It'll be indexed. If you don't want something public, you have to either not put it on the server at all or put real access control on it, so somebody has to log in first to see it. All right. And so best practices, evaluate your document access control requirements for every unit. This is why it's so difficult, because somebody makes the website and then people are always changing it and always adding new features and connecting it to other things. And that's why it keeps on happening that somebody connects something and forgets to do the authorization part. Because if you do, it will still work for normal users and you won't immediately notice that anything is wrong. All right, use a central component to check access controls. Use it for every client request. This is the right way to do it, so that one central location has everybody's identity and what role they have, and you always use that to authenticate them. Otherwise, you're going to have problems. If you have two separate authentication things, then you're going to have trouble keeping them synchronized, and they won't really operate the same way. That's why, in Windows domains, you have one domain controller. All authorization and access control goes through one machine, which has one database just for this purpose, and there's nothing else you use, except you might have a backup domain controller that is identical, but you don't have two ways to log in. Everything has to always go to the single point of control. All right. And you might also further restrict by IP address, so people have to be actually on location at your company to use certain sensitive things, that sort of thing. And you can't trust anything from the client. Everything on the client can be modified with a tool like Burp. And you really should be using two-factor authentication for security critical things. And these days, you should probably just consider using two-factor authentication universally everywhere. That's where everybody should be going. Almost nobody's doing it yet because it's expensive and difficult. But I think there's no escape. I think that's where we're all going to have to go. All right, and like I say, central access control is obvious. One central location that controls security is essentially the only way to keep control of things, and Windows figured this out 20 years ago, and that's why they invented domains and domain controllers. They said you can't have a network larger than 10 machines without having a domain controller, because you'll never be able to keep them synchronized and keep all the user accounts correctly configured if you don't have one central point of administration. So you have some kind of chart like this listing all the parts of your app and all the types of users and what they can do and what they can't do. It can get complicated, but that's what you have to do. You have to figure out who people are. All right. And so this one's not that important. Let's just go to the Cahoots, Chapter 8. All right. Let's see if sorting, there's 9. 7, all right, let's see if sorting helps. Aha, 8. Okay, good. All right. Merlin, that's cute. Give it a little more time. All right, so what kind of attack accesses pages out of order? They call that logic exploitation. You defeat the logic. That was in the projects. We did that last time. There was a page where you could log in and then it asked for a two-factor code to get you to your personal page, but you could just skip past the part where you enter the two-factor code and get in without the second factor by going from page 1 to page 3, skipping page 2. All right. All right, what kind of attack happens if you read somebody else's email? Yep, that's horizontal escalation from one user to another user with the same privileges, but still someplace that you should not be able to go. All right, which technique is security through obscurity? Yeah, that's unprotected functionality. This is like hiding a key under the mat. Something important is not actually protected by a barrier. It's just concealed where you hope people won't find it. And once they find it, you have no security. All right. All right. Which defense do you bypass with a proxy server? This is a location-based control. This is what North Koreans are doing all the time. A ton of North Koreans are applying for work in technical American companies, and then they have people in America that set up a bunch of servers in their house, and they go through those as a proxy, so they appear to be in America. And then they always say their camera is broken, so they can't use the camera, and they use ChatGPT to write their responses to interviews and such. It's a big problem. Everybody finds if they hire people, you're hiring a bunch of sort of fake workers from North Korea who get in, and then they steal your company secrets and exploit your company. It's a big problem. And since everything's remote now, it's real hard to identify them. I try to, nope. They'll have to tell me who they are if they want the points. Futani, that's a real name, I think. And Grace Town, I think I know who that is. All right, good. So, all right. Let's go to the next bit. We're done with Chapter 8, and we're going to do the first part of Chapter 9. So, Chapter 9 is databases, and I used to be a database analyst for years, so I like this stuff, but it is pretty confusing. That's why I broke it up into two chunks for people that haven't done database administration. So typically you have SQL, XML, and LDAP. SQL is by far the most common structured query language, and this is a very high-value target for attackers. It has a lot of data, credit card numbers, customer employees, social security numbers, and all that jazz. SQL injection was the #1 vulnerability in web apps, and maybe it still is, for a long time responsible for more than 90% of all stolen data. I think this is no longer true, not because SQL injection became less dangerous, but because Amazon invented EC2 buckets, where you can put your data in the cloud, and for years, by default, when you did that, it was just available to the whole world. And people didn't know that, so tons of people put their data in the cloud and accidentally exposed it to the whole world, and this happened for many years, and I think it managed to lose even more data than SQL injection had lost. So anyway, those are really big errors that lose, millions or billions of records at a time. So, now, interpreted languages like SQL, the code is not compiled, it's executed line by line. SQL is one of the many languages that run this way. So the fundamental problem here is code injection, and let me see if I can open this one here to show you if you haven't taken the exploitation classes. and you may not have seen this. Okay, there should be ping command injection. All right, this is a very common flaw. If you go to your router's configuration page, there'll be a page to test an IP address. So you can put in like IP address and then ping it. So I can put in, say, the loopback address and ping it. And what happens is you see the output of the command line ping command. So the developer who wrote this page, which would be me, instead of actually figuring out how to do a ping in PHP, they just wrote a line of bash command line and passed it to the bash command processor. And that means you can add extra commands here, like ID. It'll do, what it's doing is ping minus C2 followed by the address from the user. But if you put a semicolon, you can put a second command on the same line. So now it executes the ping and then it runs the ID command to tell you who you are. And this is the Apache default user, www.data. So you can do commands here. This is command injection, so I can do an ls, for example, to list all the files in the directory on the server, and you see them there, and so on. So this is command injection. It's real easy to exploit. It's fairly common, and unfortunately, SQL injection is just the same thing, except you inject in this language called SQL, which is less familiar. But the point is you can put in a special character, like the semicolon, and in SQL, it's usually the apostrophe, and then the next text you put in is interpreted not as data, but as a command on the server. So you, as just a user, you should only have the right to send data to the server, but because of this error, you can actually send commands to the server as if you were the server administrator. So as you see, it's very dangerous. All right. So compiled languages don't usually have this flaw, although it can happen. And we do this in the exploit class. You have to write your exploits in machine language, most commonly there. So you can bypass a login. So here's the code that sees if you can log in. Select star from users where username equals Marcus and password equals secret. This is only going to let you in if you put in the correct username and password, and these values, username and password, came from the user. So if I put in admin apostrophe dash dash as the username, then it turns into this, select star from users where username equals admin, and the rest of this command is ignored because the dash dash starts a comment. So now it lets me in as the admin without checking the password at all. This is one simple case of SQL injection. I'm able to modify the code by adding the comment signal, so I'm able to remove some of the code the developer put there and change the logic of the app. All right, you can also put in this one, apostrophe or 1 equals 1. That would do this where username is empty or 1 equals 1, and then ignore all the rest. And this will usually authenticate as the first identity in the database, which is usually the administrator. So even if you don't know the administrator's name, you can often get in this way. That's the sort of thing. And so we'll do this. We'll do this in the project. We're doing it just today. We'll be doing some more of these, and we did some last time in the Web Security Academy. So the union operator combines two select statements. So you can do something like this, where you select username for users, or username like this, union another select. So you can just add a second select. So here's the first one. It finds this name, Herc Derper, and the next select finds the social security numbers. And we'll do that in the project, and you've done it before, the project I wrote here. So the comment symbol is important, and some apps use different things. Pound is, I think, for Linux, MySQL. Microsoft Server, it tends to be dash dash. Sometimes it's slash star. I have to try different comment symbols to get it to work. All right, and union, the two fields, the two select queries that you add together must have the same number of fields and data types. And we'll see that in the projects we're going to do later today. You'll see how you handle that. If you have the wrong number of columns, you get an error like this. The use select statements have a different number of columns. So if you can see the SQL error messages, which really ought to be turned off on production servers, but sometimes they leave them turned on, that makes it pretty easy to do SQL injection because you get helpful error messages. If you have different data types, you will have a field that can take anything. A string field can take a number or a string, so that's handy. A numerical field has to take only a number, so it can give you a real problem. So the first thing you do is, I'm going to do this in the projects right after this, you find the number of columns. And the most general way to do it is to select null, because null is an empty object that will fit in any data type. It'll fit in a string, currency, numbers, anything. So if you select null, this will work if you have the right number of columns and not if you don't. So you just try different numbers of nulls until you don't get an error, and then you'll know how many columns there are. All right, then you can do this. You can put in a letter and then nulls and try it in different fields to find out which field is alphabetical, if any of them are. That's what you want. You're hoping to have an alphabetical field because that's the most general. And then you can do things like find the database version with that version. That will give you some information. And anyway, this is kind of funny. In 2013, a San Francisco college was like this, and somebody had left this in Google. There was a SQL injection. You see it here. ID is -1, union, select, group concat, all this jazz, and it dumped the administrator password and the administrator name. And I tried to tell these guys, and I couldn't get them to care. Eventually, they took down the server, and it's gone. I could never crack this hash either. I couldn't figure out what kind of hash it was. But anyway, I said, dude, this is not good. But I couldn't get anybody to pay attention, which is typically when I notify people. Anyway, Microsoft has a SQL Server too, and so you can search for, say, name equals Matthew and get information. And so if you can inject, you can try selecting null and keep going until it turns out in this case you have to have 5 nulls to get another field replying empty. So that means until then you'll get the message saying there's the wrong number of columns. And then you have to find a string column. So you find the first column is a string. You have A, null, 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 and the A appears here. So now that you've found that, now you can ask for things. You can get table name and column name, null, 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 from information schema columns. So here you get tables and column names. So you can see there's a table named users with the fields named username and password. So now you can ask for username, password from users and get them all. And this is the general process that you go through for SQL injection. First you find the names of the tables, then you find the names of the columns, then you ask for what you want. All right, let's try the Kahoot for chapter 9a, which is here. And then we'll go into the Web Security Academy and do these attacks. You'll see they're quite easy in there, where everything is set up to be nice and clean for you. If you do live capture the flag events, it's more difficult because the syntax is always a little different and you have to try a lot of variations to get anything to work. Whenever you're doing this kind of attack, keep a lot of notes. That's what I would have, a notepad file or something. Keep track of what you did, especially keep track of anything that works. Because you have to try a lot of options until something works, and then you have to modify it. And very often you have to go back several steps back to the one that worked and try modifying it differently. Most important thing is keep good notes. It takes a lot of queries and a lot of long injections that look very much the same. You can't remember them and keep them straight. You have to keep good notes. Nope, no points. All right, well, that's clear. If Nope doesn't care about points, that's fine. Guests are welcome. And there's some students that just don't care about points for various reasons. That's fine too. The customer is always right. All right. All right. So what SQL method combines 2 queries together? That's union. Union lets you have one select query the administrator put there, and now you can add another select query, and the 2 get added together. All right. All right, so what's the point of selecting null null? What would that do? Yeah, you find the number of columns. This will give you an error until you have the right number of nulls, and then you won't have an error, and that tells you how many columns there are in the select query the administrator wrote, which you can't see. This is how you can get some information about it. All right, so which is the free open source database? MySQL. Therefore, it's the one I use most often because I'm in an impoverished college. That's the open source free one, typically running on Linux. All right, if this injection succeeds, what have you learned? Select null, A null. The second column is a string. If that succeeds, the A went in there, so that's useful. Right. JSON. Right. All right, good. So, stop this recording.